Hello, this is Dr. Bimal Kumar Sarkar has come to the lab of Institute of Materials, Faculty of Material Science, Slovak University of Technology at Strnava, Slovakia. This lab is doing work on the improvement of steel alloys. They're working on the just enhancement of the mechanical properties of steel alloys, mostly at just absolute extreme condition, that is at a very high temperature pressure. Most importantly, it is required for the just structural material formation. This lab is doing work on the enhancement of some alloys so that these alloys can be used in extreme conditions. So just here I have come on a project for the improvement of the mechanical properties and stability of such kind of intermetallic compound, zirconium aluminum alloys, to improve the mechanical properties. So on that project, I'm in this lab for just some work here. I've come here at the position of a visiting professor so to take part in the research program and also some just exchange program. So I'll be doing work on this just alloy strength enhancement. For example, still now that some intermetallic compound, zirconium aluminum, is very important for the scientific and technological significance because it is very useful for structural applications in thermal reactors because it has relatively simple crystal structure, having very isotropic properties, potential toughness. Its specific thermal neutron absorption capture cross-section is around 1 meter square per meter cube in comparison to 17 meter square per meter cube in iron. So this compound has interesting mechanical properties, and some of them are the following. The yield strength increases with increase in temperature, and its work hardening rate exceeds that of any excessive polycrystals. But one problem is there. The problem is that it swells on irradiation and just undergoes an embrittle crystalline to amorphous phase transformation when irradiated at temperature less than 400 degrees Celsius. So irradiation-induced amorphization has been observed in this kind of materials. To improve this, it has been thought that by just doing some doping of kind of just transition metal into this zirconium alloy, it can improve the mechanical properties and ductility useful for the just extreme condition structural utility. So basically just we're thinking to dope just some transition metal, niobium, in the just alloy of zirconium alloy, aluminum alloy, and then it will improve the vortex ratio there also. And our just objective and plan is that prepare some doping of niobium in zirconium aluminum alloy, then just to study the morphological study and also characterize it. It will be studied, characterized under same chain, etc. for morphological study already being done. And after characterization, then we have to see the improvement in mechanical properties. Then it will be tested under mechanical lab, and also it will be tested under the laser plating there also. So to see that how much their strength has been increased the doping of niobium in zirconium aluminum alloys. So in this way, we can just, we'll see the effect of niobium just doping is such kind of alloy to improve this. So this is the work on which just I have taken on just a proposal to do some work in collaboration with the lab of Institute of Materials, Faculty of Material Science and Engineering, the Institute of Material Science in Slovak University of Technology at Trinidad. So this is the project just with which I've come here in assignment as a visiting professor in this lab to do work and to improve the mechanical properties of such kind of just alloys. So this is my work, and thank you very much for observing this just idea and doing work in this lab. Thank you very much.